damper. So these are devices that are referenced and utilized years beyond the project as they need to be tested in healthcare facilities every 6 years, and then other buildings, every 4 years, and other buildings every 6 years. So we find that it's important for those to actually be scheduled, which helps with the coordination process as well.
And maybe, Rachel and I are going back and forth on this, and we're not sure if this is just a Midwestern thing of oftentimes us having to bring to people's attention that life safety dampers should be scheduled. We look at them like a VAV box, and a VAV box most definitely gets scheduled. So something that actually has the title of life safety associated with them should certainly also be scheduled. It allows then right up front to have an individual identity that everyone could respond to and be talking about the same thing versus this is a damper by column line AA/6.
And this moves right into these should be coordinated. So obviously if they're scheduled, it makes the coordination process easier as well. There are numerous trade interdependencies and trade-aligned responsibilities that come with these life safety dampers. The engineer has a large job to wrap their arms around the process and the people that are involved in the utilization of these dampers. They touch the architect, the mechanical engineer, the fire alarm contractor, the electrical contractor, the AHJ, the CX, and they touch so many folks, and so many people have, a small responsibility or a large responsibility depending on the outcome of that particular project. So it's really important to get your arms wrapped around that early in the process, and it makes everything go smoother in the end. Codes. Here are a list of codes, and just to kind of, we're talking to people from everywhere right now, and maybe we're a little bit slow here in Wisconsin, but we're still using the IMC 2009, and obviously that varies throughout the United States and what folks are adopting and not. But over here, this is what we're utilizing. The codes that you see listed on the screen between the IMC and the NFPA 90A and 72 and the UL 864 and other ones, we'll touch on those more in the presentation, but items that we are indicating may have, Wisconsinisms, quote unquote, in those, so they would need to be verified on your end for your location. So miscellaneous code tidbits. As we are not in front of you, we're not going to be able to see you raising your hand with an answer. So please feel free to just take a couple seconds to think of your answer. Oh, okay. Don't click it yet, but we're going to go back. What allows an entity to be able to have a fire, to have the first duct detector be a supervisory versus a fire alarm?
The fire alarm systems, little delay there. When fire alarm systems are monitored 24/7, a person on site, the smoke duct detectors can be set up as a supervisory device. But if they're not monitored 24/7 with an entity on site, more or less at a fire alarm panel, then those devices would have to be a fire alarm, which would then roll the fire trucks. So depends on the entity that you are building and how it's being monitored on whether or not a duct detector is supervisory or an alarm. Does a UL-listed fire alarm system require alternate devices, alternate installation strategies, or both? Next. So the answer is alternate devices. And if you click there, where we're going is kind of from the UL 864, where that is actually really just applying to the actual pieces of a fire alarm equipment, the components themselves. It doesn't dig into how the systems are actually installed.
Where is survivable wire required? So really, survivable wire is required from the source of origination to a fire pump, It's required from the source of origination to the stairwell that requires sterile pressurization. Obviously, once you enter that zone of sterile pressurization, you can then run in your just regular wire or rings and strings. It's kind of like duct now, where you almost can't penetrate through into a stair zone. You need survivable wire when you're going panel to panel, or any notification of client circuit. And the source of origination to your evacuation zone serves. So sometimes you're crossing zones. You need your survivable wire from your origination through the multiple zones, but once you get into your zone, then you can run it in your regular wire or your rings and strings.
So we always like to have little riddles. You know, what did the monitor module say to the control module? And the answer is nothing. They do not talk to one another. And does this sound familiar? And what we want to kind of, like we're kind of indicating here, and I think likely on, you know, jobs that, I say, our jobs are commissioning-led projects. These are probably not as big of issues, and these are just things that we do to kind of spearhead this stuff to not allow these types of things to happen. But when those type of jobs, or those, now I just got myself tongue-tied there, sorry. When the commissioning process isn't invoked, that's again when we come to a lot of these problems that we are presenting and talking about. But control modules, and the reason that we want to just identify control modules and monitor modules is that when we're listening to people out in the field, between the owner or even the contractors, they're throwing around terms so often, and they make them sound like they're synonymous, and they're really not. You know, the control module is taking that output from the fire alarm panel, and it's telling another entity, which could be controls, it could be door hardware, it could be many different things, that an event is occurring in the fire alarm, and the system needs to respond accordingly. Conversely, a monitor module is those remote entities that are sending an input into the fire alarm panel so that the fire alarm panel knows that there is a condition that is happening outside of the system. It could be an HVAC occupancy signal. It could be other signals, even again from door hardware. So installation of life safety dampers. The first line that we have indicated here is something that we hear so often. We talk to the framers, or we're talking to the sheet metal foreman or the guys doing the work, and so oftentimes one of the first things that have been coming out of their mouth is that, hey, we've installed fire smoke dampers, fire dampers the same way for over 30 years. So after we have our little eye roll that they don't see, that we have to then politely indicate to them saying, no, you are likely been installing those fire smoke dampers or fire dampers wrong for probably at least the last 25. Because manufacturers are continually changing and getting their devices recertified under UL processes, and those framing techniques change.
So it's very important for an HVAC contractor to share the installation manual with the framing contractor. In the end, no matter what the design documents state, that installation manual is going to trump the design detail, as these are UL-listed devices, and they do have specific requirements in order to make them functional in the manner that they were tested. Manufacturer's installation manual discusses many details, such as the proper framing techniques, when fire caulking is required versus not required, retaining angles, including the screw depth, where they get screwed to, how often you need a screw through them, and accessibility. So we'll get into these a little bit more, but regarding the thermal links, the thermal disc reset switches or fusible links, access doors, your duct detectors, your sensing wands, and the damper itself, and the actuator. So here are just a couple photos of some, and these are just from this year for us. So I mean, we're finding this everywhere. These are photos of improper framing of dampers. So there's no horizontal. I should probably take the little, allow me to highlight briefly. You can tell there's no screws in the drywall indicating that there's framing underneath this drawing. How do you know? Sorry, technical difficulties, just trying to move to the next screen. Here you can see that there's no, once again, there's no horizontal framing underneath the damper. Next. Likewise, on the shaft wall, you can see there is no framing around the damper anywhere. And similarly here. On this, you can see that the fire smoke damper is fire caulked into the wall, and that is a no-no. You do not fire caulk fire dampers or fire smoke dampers. You can fire caulk smoke damper, but in regards to fire smoke dampers and fire dampers, you need a retaining angle, and then you can, should you choose, caulk the retaining angle. And here we have one of those said retaining angles, and you can see that the screws are missing. So these retaining angles have not been screwed in the sleeve or the wall where they're supposed to be. Here's some good examples. As you can see, these dampers show they show framing underneath. It's important to see that these dampers have a vertical stud that extends from the floor to the deck. Then the horizontal studs go and connect to those full-length vertical studs. So this is, I'm going to attempt the highlighter again. I apologize if I get us messed up. We've got these horizontal studs here that are going on, that are connecting to these vertical ones that go all the way up and all the way down. And then because it doesn't fully fill in the space, then they connect this intermittent one to those two that went to the full vertical. Over on this side, you can see they had proper spacing for their studs, and they chose to add a full additional another stud to connect their horizontals to. So there are numerous ways, as Dave would say, there's numerous ways to skin a cat or to eat an Oreo. But this is these are a couple examples of what you want to look for when you're looking for framing. Here, installation manual, you can see what I was indicating, where you've got two full height vertical studs, and those horizontals tap into those. Here's another detail of that where you're tapping into it, but it was a duct that is not the size of the opening, so this is the way that you can deal with that with your additional little vertical elements. Here we are talking about retaining angles, and it discusses some drywall screws and what length they need to be or how far they need to penetrate through the framing, how often they need to be. Here you can see, and it actually, I'm going to breeze on to the next screen because it's pretty much the same thing. This is discussing the retaining angles and how they're supported. So sometimes it's hard to get to both sides of the wall, for example, on a shaft wall. So you can utilize retaining angles on just one side of the wall, and if you do so, you have to screw both into the sleeve and into the wall. And there are different requirements for how far apart the spacing of those screws need to be, whether it's in the wall or the sleeve. If you have your retaining angle on both sides of the wall, which is probably most common, then you just screw into the sleeve of the damper, not into the wall. And obviously, keep in mind always that dampers are different, and while there are similarities between the manufacturers, they still have their differences.
So for, what we want to just illustrate here is that, there are examples of people trying to do the right thing. And here was a contractor that wrote an RFI and said manufacturer's instructions, installation instructions, which were attached, which we think is fantastic. We love it when the contractors are actually trying to provide a solution, especially when they oftentimes have ones in mind anyways. For the shaft wall framing and construction around the fire and smoke dampers are inconsistent with the shaft wall type identified on the architectural drawing A0100. specifically with the 2 layers of drywall on the room side of a wall. Please advise which detail should be followed. So what they were kind of indicating there is, do we follow the detail on the architectural plan, or do we follow the detail on the owner's instructions or the manufacturer's instructions? So what we did, because we were asked to take a look at this along with the architect, they asked us to tag team with them, is that we went and we actually reviewed their detail, which we thought actually provided some good general information pertaining to their wall types. But then we went and reviewed the documentation the contractor provided, and it ended up not being the manufacturer installation data sheet for the particular fire smoke damper in question. So we went and searched for the proper green heck, in this instance, fire alarm or fire smoke damper installation manual, and we observed those details. Spoke to the architect about this, and then the architect replied accordingly with a statement that pretty much indicated, you can pop the next, there you go, Peggy, thank you, that, well, I think the first thing that they did, which is, I think, a good thing, is that they indicated that their detail was correct. And they also then indicated that the detail that the contractor provided was not correct. But really the most important thing they are stating is you need to refer to the installation instructions so that they actually get constructed properly. And also making sure, again, that that framing contractor is aware and give them the information to help them be successful. So, again, really good intentions. Didn't have the exact outcome that maybe the contractor was anticipating, but everyone was able to move forward, and this is absolutely getting installed the correct way.
So hot potato. This is how we see fire alarm and control. Whose is it, I say? Just keep clicking.
Not mine, says the control contractor.
Whose is it, I say again?
Not mine, says the fire alarm contractor.
Whose is it, I say again and again?
It's not mine, it says all the others.
So this is just a kind of visual of how the finger pointing is at the end of a process when we're trying to figure out who's responsible for what when it comes to controlling dampers.
And maybe one reason that, there is the, the control aspect and the fire alarm aspect are these 2 code references, NFPA 90A and in IMC 2009 with these sections that are identified here. And most importantly, if we just kind of look at the paragraph on the left-hand side, 6.34, it's talking about the, fire smoke dampers are permitted to remain open when the fan is off, provided that, the controlling actuator and alarm devices remain operational. So the question is, do all the devices remain operational during all operating conditions? So what we did, next page, Peggy, is quite simply just went to the main detection device that's providing the signal in the first place. And I just actually searched for specifications on all sorts of them and just planted out a couple of them that I found here. And if you notice, both of these have air velocity readings, a minimum and a maximum. And what's also interesting is that the ratings aren't even the same between them. One does have I would say, a significantly lower feet per minute requirement. But the most important fact on this is that all of them have a minimum velocity. The low end is not 0. So when an air handling unit is off, the velocity would be 0 for all practical purposes. Hence, the duct smoke detector becomes non-operational, non-functional when the air handling unit is off. So now these 2 code references play a much bigger role, still with the NFPA 90, as we've highlighted there, but I think it's actually better illustrated in the IMC under that subparagraph 1, where it indicates other than mechanical smoke control systems, dampers shall close upon fan shutdown where local smoke detection require a minimum velocity to operate. So what we're looking at here is that this is really the marriage between fire alarm and controls.
Right, kind of going off of what Dave said. It doesn't matter why the fan is shut down. If the fan is shut down for a fire alarm condition or for a control condition, such as a safety or maintenance.
Or even an occupancy schedule, right? Yes.
Yes.
So things that, we do and look at, and again, one thing, that we just wanted to throw out there is we're not talking and identifying that these devices would have a construction verification sheet or a functional test sheet associated, because I believe we would all understand for what we all likely provide as our services that there would be a construction verification sheet and there would be a functional test. So we're really not getting into the nuts and bolts of that. But let's make sure that our duct detector is located properly within the duct. And the reason that we indicate this is that really all ducts, especially during construction, virtually look the same. And how is sometimes an electrician, and not necessarily poking at them, actually even know the direction of air in a vertical shaft or a vertical shaft, because maybe he doesn't even know where the air handling unit is located. Is the air handling unit in the basement, or is the air handling unit located up in the penthouse? So which direction does the airflow go? We're not even going to go if there is one in the penthouse and in the penthouse, but we'll stop there. But so orientation of that duct detector sensing tube is very important. We're always peeking our head into the access doors to make sure they're the right direction. We also advocate during training that the owner, when they're doing their inspections, they're in there looking already, that they should just make sure that, again, the sensing tubes are pointed in the correct direction. Next, air velocity readings. When you read the operation and installation instructions with the minimum velocities, they should really be checked. But does our team necessarily check every single duct detector for minimum velocity? No, we do not. We actually pay attention to where the duct is actually located. If we're in a main air shaft, high pressure duct work, we're just going to take a little bit of a look at where the expected airflows are, and we would have a confidence level that we would be at adequate velocity. But if we're talking about a low pressure return duct or a transfer duct or something with that, then we would be far more concerned, and we would want to go and sense it or prove that it has the proper velocity, which is very simple to do by just putting a magnet helix across the sensing tubes.
So who is it? We see this as typically having three typical options on how these systems are controlled. Obviously, there are numerous hybrids when it comes to this, but really we're looking at, for the purpose of this presentation, controls operating the fire smoke dampers, fire alarm operating the dampers, and both controls and fire alarm operating the dampers for their various reasons. Obviously, there's hybrids, but we're not going to dig too deep into those on this presentation.
So where controls operates the dampers, the pros, where we see this is typically on, smaller office buildings, clinics, medical office buildings like we've indicated here. It's a simple shutdown of kind of a one goes, all goes entire system upon activation. Individual damper controls still can occur, and depending on how the control contractor would power these up, because typically the control person would be the one that controls and powers these devices. Also, though, a con and can be the reciprocal of a pro, depending on, again, how the control contractor is powering these devices, might not make it as easy for individual damper control, and where that mainly becomes an issue is when you are doing the annual or every number of year inspection. So what we've created here is just kind of a little diagrammatic sketch to kind of illustrate what's going on. We would have that duct detector sitting on the fire alarm network, and there would typically be a control module that could be activating that individual duct or fire smoke damper, but doesn't necessarily have to be the case. The more important module is the one that's kind of on the center left, which is the fire alarm control module that oftentimes in specifications around here in Wisconsin, and it's actually in code where it says, control module will be located within 5 feet of a temperature control panel. This device here can actually be used to energize, de-energize a whole bank of powered fire smoke dampers. And typically in series with that would be then a control-mounted relay that whenever the air handling unit is off, again, they can remove power, which would in turn close all the dampers when the unit is off based on occupancy, safety, or more importantly, when it's off on fire alarm. End switches, which we show there, they could be wired in series as part of a interlock system, or those end switches could be interconnected to individual binary outputs in the automation system where people can make judgment calls working with the designer saying, let's just say it's a simple 4-story building, maybe we only need to have, we're going to make the consideration that if we have at least 2 supply dampers in a shaft and 2 return dampers of the 4 open, then that is adequate to allow us to move air. Potentially interlocking every damper is oftentimes a little bit over the top, and because there are safeties within the air handling unit, static safeties to turn it off and protect it from an oops situation.
Next, we'll look at fire alarm operates the dampers. So a pro here is only one entity touching the fire smoke dampers, the smoke dampers. So you don't have controls doing one thing and fire alarm doing another. The cons, the fire alarm contractor doesn't necessarily tend to be quite as in sync with the sequences or what the functionalities of the dampers are supposed to be at all times, or even which dampers belong to which systems. And you also tend to require monitor modules at each fan system. So here, we've got, diagrammatically, we've got the duct smoke detector that detects smoke, and it sends a signal to the fire alarm panel, which sends a signal to close its associated damper. You also have this monitor module here that is basically listening. So Dave kind of went over how the control module sends out the signal. The monitor module is listening. So when the air handler, for example, goes down for any reason, let's say a low limit safety or static pressure, or it's just down for maintenance, this monitor module sees, oh, this system is down, and it sends a signal back to the fire alarm panel and says, hey, this system's down. Fire alarm panel sends out a signal for all the dampers to close. So the fire alarm is closing the dampers for reasons related to the control side, not just the fire alarm side. This is typically something that's done more in a 24/7 building. This is similar to what Dave had talked about before with having a building that's monitored 24/7. If the fire alarm is performing a function, it has to come with one of three things. That's a supervisory, a fire alarm, or a trouble. And anything that the fire alarm produces needs to be acknowledged. So if you are in a building that has an occupancy schedule, so it's off at night, and your fire alarm is doing the work, then every single morning when you come in, you'll be going to your fire alarm panel and clearing your supervisory. So typically you don't see this method utilized in buildings with schedules that are not monitored. Similarly, the end switches, though they don't have any control aspect to them, they can be monitored. So you can still utilize your end switches from a control perspective so that you can monitor the status of your dampers.
Controls and fire alarm operating the damper. The pros, each entity operates, the damper or dampers, independently of each other. They both can do whatever they want to an individual fire smoke damper. Larger schemes can also happen. The cons, this is typically a little more of an expensive type of installation. But using, again, our same basic diagram, we do have the duct detection that, again, has a control module that's within close proximity of the fire smoke damper itself. But in very close proximity to that, there is a control relay that is in series with the power connection that whenever, again, the HVAC system were to go off for whatever reason, that relay could be made to open and in turn tell the fire smoke damper to close. This can be a system that could be wired 120 volt by the electrician. It could be wired 24 volt by the control contractor, but the main purpose of that is that the power feed to these relays would be a continuous power source. And again, as Rachel has indicated, the end switches are there. We believe that they're important to be utilized, whether or not you are going to use them for control or at least monitoring them to know that they are opened or closed. There is always the decision of which end switch do you monitor. Do you monitor them both, or do you monitor the end switch that proves that the damper is really closed, the one that would change the state at around the 10-degree mark, or do you use the other relay or the other contact, which changes state at around the 80-degree rotation mark? Next slide.
So testing. Oftentimes we find common problems when we go to test a damper, like there's a screw in the sleeve. And while contractors do tend to stroke their dampers open and close when they install them, construction continues and things happen. So it's important at the end of the process to test these dampers. Many times we find missing access doors where you can't even see the damper, or the damper's fire caulked into the wall, or retaining angles aren't screwed properly, or you have an accessibility concern. So we're always looking to confirm that all components, all applicable components are accessible. All labels, many facilities utilize an acid tagging process, and then there's also your device tag, and many times there's a ceiling grid tag associated with these devices. Is your duct detector sensing tube facing the appropriate direction? As Dave had discussed earlier, or are they openings into the airstream? Does your damper fully open and close? So defining methods of testing, we've got for a fire damper, it can really be as simple as removing a fusible link, confirming the damper fully closes, and resetting the link. So obviously you have to have an access door that's accessible, and then you have to be able to reach through that access door in a safe manner to be able to perform that function. This is something that a facility does need to do every 4 or 6 years, depending on the type of building that you're in. For fire smoke and smoke damper testing, there are multiple ways to accomplish this, and it all depends on your end goal. For example, key switches and magnets, really, they test the detector electronics, and while you are able to verify that the damper does fully open and fully close and verify your naming conventions that come back to the fire alarm panel, that is pretty much the extent of what those test. They don't really test any sensors in the device itself. From a code perspective, before occupancy, and this the AHJ usually participates in, they need to test with smoke. So it could be smoke through the detector itself, or it could be smoke in the duct at the wand. If you're just looking to see the damper fully open and fully closed and the controls is controlling them, you could command them open and close. There's also the thermal disk reset button. So this here is a picture of a single thermal disk. This is basically part of a fire smoke damper. It's the fire aspect of a fire smoke damper. So you have this little reset button and disk that's on the side of your duct. So when these are in place, you need to be able to have access to push these on the inside to release the disk. So you're pushing the button. It basically pops the fusible link, per se, so that it removes the power and allows that fire smoke damper to close. And then on the outside, so here on the left picture, you can see the, I'll grab my little highlighter tool right here. You can see In many of them, you push here, and on the outside, you reset here. So this puts it back into place, and this is really testing the 165-degree rated fusible link that's in your this part of your thermal disk. Nope, this is good.
But there are also thermal disks that actually have dual sensing elements for a system that's associated oftentimes with the firefighter control panel, where the firefighter control panel needs to actually allow the damper to go back open based on a human request by a firefighter. So as this is illustrating here, typically there is still these smoke detector that would have a broken contact, but there is the 165-degree element. But if that were to trip, or even the smoke detection going off, if the firefighter wanted that damper to go open, they would actually have the ability to put that in hand and, again, re-energize the actuator to open it. But there is a fail-safe 250-degree thermal link that would be utilized to say, hey, this is just past even what the firefighter wants it to be, and it's, again, going to be recommanding the actuator closed. That's all I have. There we go. So here's an example of that. If you look at the drawing on the left-hand side, it actually shows the two thermal disk elements there, and then on the front side, the reset buttons, which from our experiences, and because we're not exactly sure, I don't want to say how we're not exactly sure how it works, but the 250-degree one, there's a little more oomph that's needed to push that reset button back. So we're indicating this with the handoff, and as you can likely tell, Rachel and I kind of like Star Wars. You know, it's really important that, you know, this information, us as commissioning providers, you know, we're handing things off to make people aware that, you know, of their responsibilities, and, you know, and really tying people together, like many people do already, you know, like having controls page turns, you know, really digging into the weeds with controls. We've also learned that there are values to do that with the fire alarm contractor, because fire alarms are actually programmed devices also. We didn't even get into the weeds of that, but, you know, there is that possibility that they might have the wrong detector, you know, going to activate a wrong actuator. I mean, those possibilities can happen, and sometimes on a one goes, all goes system, that's not near as easy to necessarily individually identify unless you truly test it individually, which it should be, but those are some of the questions we have. Rachel, I don't know if you have anything additional to add.
No, I think that's good. I just wanted to say sorry for all the gaps that were out there. This is part of the delay process between North Carolina and Wisconsin.
No worries. We did have a couple of questions come in, guys. You want me to ask those now? You ready for them?
Sure.
So this one was back a little bit. This is when DDC controls are operating the damper. I believe their system needs to be certified for use in a life safety scenario. Is this correct? Our experience is that control systems are typically not certified.
That does go back to the slide.
I think that's a root. Okay, I'll take the first swing at that one. Controls really are not, you know, they're not controlling the fire smoke damper through the building automation system. And even our diagrams were kind of trying to illustrate that really well. Everything's being done by electromechanical means and relays. Everything's hardwired connected. It's done by the controls, you know, the control contractor doing the work, but it is not it's not being operated through any building management system or controls, because you are absolutely correct. I mean, Johnson Controls has a product line that can be used as part of a engineered smoke control system, where many other systems do not have that capability to do.
Right, and like kind of where Dave had discussed in the presentation earlier, that UL 864, it discusses that it's the devices, not so much how the systems are installed or wired.
And, and again, this is my last, in the state of Wisconsin, and using the state as an example, you know, they're believing that, you know, the controls are wired fail-safe. So when they're fail-safe, the dampers are going to go closed. So that's all that has to happen. They don't have to be commanded open. They only have to be closed. So if something bad happens with the control system, someone cuts a wire, a fuse blows or whatever, the damper closes and fails safe.
Okay, the next question was, you covered control by BAS contractor, control by FA contractor, and control by combination. Who would be included in a hybrid control arrangement? Make sense?
Well, I think the reason I think Rachel and I just kind of use the hybrid is that each one of the kind of the three basic ones we kind of threw out there, someone always, people, there's a little delay here on my own thought, but all it takes is just one little thing to change something up, and it would still allow it to work. And it could literally be the use of end switches, and necessarily sometimes who's actually, you know, powering the device. So I guess I really don't have a good, I think our three of them cover all the bases, but I think we wanted to choose the word hybrid. We didn't know the details how end switches would actually get into play.
Okay. When testing fire dampers non-motorized, do you suggest testing them all, or is a random sampling acceptable?
For our personal group, we test 100% because they are life safety dampers. They're critical items. So it is our practice to test 100% of them.
So a hotel that had 400 rooms, our arms got pretty cut up because we participated and helped and did it ourselves.
Yes.
Well, as someone who stays in one of those rooms, I appreciate that. We've had contractors refuse to remove the fusible link to test a damper for fear they cannot reset it to a factory standards. Is this ever a concern for you, or have you had that experience?
Ooh, I love this one. Well, I'm sorry. I don't know if I'm getting the feedback, causing feedback here. I hear myself, but what we put back on the contractor is, would you actually have more of a worry that you know, I guess where they're going is, if I don't touch it and if it works, you know, because it's done by the factory, then I don't have a problem. But if I touch it, I potentially mess the damper up. But what we still see more often than not is a damper potentially not being plumb, or that little tech screw that Rachel is indicating, that damper doesn't slide down. So the only way to prove that is to make the damper drop. And most of our AHJs want to see that too, and that's just something that we strive to do. And
I think it's very
important, to prove that it can be done.
Exactly. I think it's important that it happens, and oftentimes if someone has a fear of doing something, it makes us almost want to test it more, because the fear should not be there on turnover of the building. But the owner should be provided documentation that it's been tested in its current condition, just like Dave indicated, that the damper can close and open.
And if someone really refuses to do it, and you know, and maybe we'll say that, it's not accessible, and the person doesn't even have a fighting chance to get to it, that's something that someone has to make a decision to be aware of that, because that damper has to be tested, and so it should be made to work right away by the contractor.
Absolutely, and if they don't want to test it, that needs to be brought up to the owner, because if something's not going to be tested, the owner has to have awareness and acceptance of that decision. Oftentimes on our testing reports, we'll put items, like Dave used the words fighting chance. I've put, you need, a 10-foot ladder and a tall person with long arms. It seems kind of silly, but sometimes that's what's required of a particular situation, and just making them aware of that is important.
Okay, one last question before we have to close for the day. Do all the BAS devices have to be UL 864 to use the BAS for smoke control? Hope I asked that correctly.
I'm going to treat that question just like it was written as a lawyer's deposition. As the question is of a smoke control system, the answer would be yes. But if it's just actually a bunch of fire smoke dampers that need to close based on a fire alarm, and that's not a smoke control system, the answer would be no.
Perfect.
In our opinion.
In your opinion, in your humble opinion. Well, that is all the questions we have from the audience today. I want to thank everyone in the audience for being so attentive and for attending. Remember that all of the Tech Talks will be up on the website under resources. You'll find them there under Tech Talks. This is for a member-only benefit, so you will have all of these available as member as long as you renew your membership. The code to access them once you get to that spot is TechTalks 2017. That will work for all of this year's Tech Talks. So please make sure you go ahead and use that and review them. This one should be up in the next day or so. We'll get the recording down and get it uploaded, and you'll be able to see it again. With that, I want to thank our two speakers for today for putting this together for all of our members. We really appreciate it. Next month in January, the California chapter will be putting their presentation together and presenting it. We'll get the details on that out to you all shortly. And so, again, thank you all for attending, and happy holidays. Please be safe and enjoy your families.
Thank you, Liz.
Yep.